Now I would like to give you a live demonstration of how the Edge Panfocal 3D software controls the Edge research microscope. So let's just click here on the Edge icon, and that will load the software. So this one software screen controls all the aspects of the microscope, including the camera, the focus, the lights, and the processing of the images. So right now you can see that the camera status is ready. It's turned on. These are the reflected lights on the left, the transmitted lights on the right. So right now we have a brain section. I'm going to use transmitted lights to look through this brain section. You can see some neurons there. And one of the first things you'll always want to do is make sure that you're focused. I'm just closing down the field stop to make sure that our condenser is centered and focused. So we're about in the middle. This is about 120 micron thick section through the brain. Now normally people would take 5 micron sections. So we're taking sections that are more than 20 times thicker and seeing it all at once and in 3D. So this is a single optical section through the middle of this. So I'm going to tell it right now to go through the entire 120 microns, and you're going to watch it take a stack. I just click take a stack, and it's going to go to the 0 position. So that's the very top of this specimen. And as you can see, it's focusing through, and every 7 microns, it's taking 18 pictures at different levels. And then what it's going to do, it's going to put all those pictures together, reconstruct them, and now they're all there, all in 3D, or I should say that's a 2D reconstruction of all of those images there. Now I'm going to click here, do the same thing that I'm going to click high res. And when it does it in high res, it's going to do the same thing, but what it's going to do is every single layer in this stack will be a 20 megapixel image. So the resolution will be extremely good, and it'll allow you to do some very interesting movies and 3D stuff. So let me just show you right here a little more about the program. So here's how we use the focus. This was a sliding bar, and as you move this up and down, it controls the focus of the microscope. Over here, you can focus the microscope using up and down arrows. You can use the arrows on your keyboard or your mouse as well by clicking here. And by setting this number, every time you click, it will take you those many microns. In this case, it's 10 microns. So right now, you can see this is the current focus position. You can see that this number is moving as it's taking that stack. So right now, we're at 77 microns out of the 120 microns that it's taking images of. Here's where we told it how to take the deep focus. We said every 7 microns, take a step. Starting at 0, going to end focus. This is a 120 micron thick section. So there were 18 pictures. And all we did was you click take a stack, and that's what it's doing right now. You can see it moving through the specimen. Now once it's collected all the images, these 20 megapixel images, and then it will begin to reconstruct them into a fully focused, to begin with, a fully focused 2D compression of these images. So right now it's working on it. So it'll come up with a view in 2D, which is a reconstruction, a compression of all the 3D images put together. But we can see that in many different ways by clicking here. These are the various viewing options. So you can see it as a rotational movie. You can see it in stereo 3D if you have a 3D computer, which the microscope comes with. Or you can see it in anaglyph 3D, which I'll be able to show you because you've got the red and green glasses, and that allows you to see it in 3D. You can generate a color depth map to see where the information, how deep the information is in microns. You can create a grayscale anaglyph, which gives you a black and white version of what you're looking at in case there's some colors that interfere with the red and green image. So right now it's done a first pass, and there we go. There's all the images now fully in focus. And now we're going to click on anaglyph, color anaglyph. So if you get out your red and green glasses, click on anaglyph, sorry. Get out your red, it's now creating the anaglyph. And if you put your red and green glasses, now you'll really be able to see not only all of them that are in focus through this 120 microns, but exactly where they are in 3D. So I'm going to click this larger screen icon here. Now you'll see it larger. So there you go. Now you see all of the microns that were, all of the neurons that were in those 120 micron thick specimen. But you see them in the foreground, you see which are in the background. You get a very accurate information about what is actually there. And as you look with the glasses, you can look at one individual neuron and see how it interacts or relates or does not relate to neighboring neurons. I'm going to go back to the control panel here and back to the compressed view. And now what I want to do is show you a very different kind of specimen. I'm going to turn off these lights. And what I want to now do is put up a very different kind of specimen, geological type of specimen. In this case, this is some sand from the volcanic sand from the Galapagos Islands, showing various types of volcanic minerals that come off of this particular island. So right now, I'm going to go to live view, and now I put different specimen in there. Now I'm going to put on the reflected lights. There's the reflected lights coming on, and there's some sand. I'm going to lower the stage because this is a thicker specimen. As I lower the stage, you'll see the individual grains of volcanic mineral come into view. We'll move the stage around a little bit and find a view to show you when I stack the images what it will look like. So here's an interesting little view here. So what I'm going to do is the first thing is I lower the stage so that I come to the top of the specimen. So right now we're lowering the stage, and I'm already past the top of the specimen, so I'm going to come back up to the top of the specimen, which is right about there. This little grain, that's the top right there. I'm going to set that as 0. That's the current start position. But I'm going to raise the stage till I get deeper into these sand grains. So I'm raising the stage. You're seeing the focus go through, and I'm going to probably set that right about there. Now I'm in the background here, and those are in focus, so I'm going to set that as the current end position. That was 400 and almost 500 micrometers. We're using a low power, using a 4x lens right now, so we're going to look at 40 micron steps. And now what we're going to do, we're going to name it Galapagos. And now we just say take a stack. And right now we're set on we're set on the 20 megapixel high resolution version of this particular, in other words, we're clicked on high res right now. So each picture in the stack will be a 20 megapixel picture. As it's collecting these, you can see that we can output the files in various ways. So I typed in the word Galapagos. That's going to give the name to every picture that I take as long as this same slide is in the field of view. It's going to save it in a directory called edge-3D, and it's going to name them sequentially starting with 1, and you can set any number here you want. Now it'll automatically save as a JPEG and a TIFF. The 2D reconstructed version automatically gets saved. But if you want to save other forms of the data, such as a stereo image, a JPS file, or an anaglyph, meaning a red-green version of stereo, or a grayscale anaglyph, you can check any of these boxes, and the ones that you check, it'll automatically save those file formats without having to go to the File Save As command. So you can save the left-right stereo images, you can save a color depth map, a grayscale depth map that tells you which each feature is in the Z dimension. You can save it as a 3D model. So right now it's focused down at the bottom of the specimen, and it's just now processing the first round of processing, and then it'll go to the second round of processing. So it'll take about 15 more seconds here. What I'm going to be able to show you is that there we go. So here's the all in focus, and now if I click this button that says 3D model, now we can actually move around the specimen and tilt it and look at different angles using a 3D model. Or we can do a rotational film. So if we make a little film here of this, I'm going to say create film. And what this is going to do, you have control over the step size, that is how many angles on the clock angle that you're looking at this rotational film from, and how many pixels in displacement, that is how extreme you want the oblique view to be when you look at the movie. So right now we've picked 9 and 15, which are good sort of default numbers. And then in a few seconds it'll have created the movie. It's put it all together. Now it's putting it into an AVI file. And you say want to view it, and you say yes. And we push enter. And now we can see, I'm going to just enlarge this here. Now we see the 3D by virtue of motion parallax. This gives you a very interesting way of seeing what's in the foreground, what's in the background, and distinguishing really what's there. So I'm going to close that out and close this out. So I want to save, I'll say no. I'll go back to live view. Now I'm going to turn off our lights. And that ends this particular demonstration of the Edge 3D and focal software. Thank you very much.